All right, good afternoon. Welcome back to the CINR seminars, or webinars, I should say. My name is Richard Reister. I'm the project manager for the Light Water Reactor Sustainability Program, and I'll be covering 3 topics this afternoon, RC 5, 6, and 7. So first, and I've got some lab staff on the line too to help me out if I need some technical assistance. So first, let me give you some a brief background on the Light Water Reactor Sustainability Program. The vision for the Light Water Reactor Sustainability Program is to keep the existing plants operating safely and economically for as long as possible. And so this has 2 goals: develop the scientific basis to support life extension and help ensure long-term economic viability, mostly through reducing technical uncertainties through long-term operation. We've organized the program into 5 main research areas: materials, aging and degradation, advanced instrumentation, information and control systems technologies, risk-informed safety margin characterization, reactor safety technologies, and finally systems analysis and emerging issues. And, sorry, I forgot to, but I'll move on to the next slide. And this provides a little bit additional information and background on those 5 areas. In the materials area, we're conducting research related to damage to nuclear core components caused by corrosion that has been accelerated from radiation. Reactor pressure vessel embrittlement, and we're also looking at concrete and cable degradation. In the instrumentation, information, and control system area, we're focused on modernizing our aging nuclear power plants, mainly through the use of digital technologies. We generally team with a host utility to develop and demonstrate how new technologies can be implemented in a real plant setting, and often we work with EPRI to publish the results so that plants can benefit so that all plants can benefit from this work. In the safety margin characterization area, we're developing and demonstrating new safety systems analysis tools, computer simulation codes such as Relapse 7 and Grizzly, to simulate the behavior of aging plants in a way that provides more comprehensive safety insights and enables a more useful risk-informed analysis of plant safety margins than can be done using existing tools. In the reactor safety technology area, we're addressing the Fukushima lessons learned. This includes helping industry make improvements in severe accident guidelines through potentially better use of available equipment. And finally, we have a systems analysis and emerging issues area, which kind of is a cats and dogs area, but we've been addressing topics such as flexible operations, water usage, and the use of lithium, and the availability of lithium-7 for chemistry control as some examples in that area. So moving on to our first topical area, it's related to the advanced instrumentation and control systems area, so I'll provide a little bit more background in that. The Light Water Reactor Sustainability Program is working to significantly reduce the technical, financial, and regulatory risk of I&C modernization. And it's important to understand we are not trying to simply replace analog with digital technologies on a like-for-like basis. Rather, we are working with asset owners and vendors to deliver greater functionality, higher reliability, improved situational awareness, and a technology base that is more affordable and sustainable over the life of the plant. In the slide, you can see on the lower left a picture of our human systems simulation laboratory at the Idaho National Laboratory. And then in the lower right, you can see a picture of with the Palo Verde, Arizona Public Service's Palo Verde Nuclear Generating Station, which won a TIP award that's issued by the Nuclear Energy Institute related to some work we did with them on outage control centers. So in some background on the first call, the The RC5 call involves applying the concept of big data analytics to existing nuclear power plants. Existing plants have a lot of data available, but often in diverse systems and in different formats. Fusing this information together to gain insights has been challenging. Big data science and data analytics offer the potential to provide real benefits. So the existing plants are beginning to modernize their infrastructure. They are adding wireless communication, wireless sensors, and digital systems which will collect data that were previously unavailable to them. We are seeking research proposals on the use of big data analytics to improve plant economics and efficiency. Proposals should address novel approaches to integrate and analyze heterogeneous data streams that will provide significant impacts on operational efficiencies. Data visualization technology should also be considered. So that's RC5. I'm going to pause here for a minute to see if there's any questions. Also, if Bruce Halbert's on the line and wants to add anything, he's welcome to come in and add a word if he's wants to. Bruce, are you on the line?
I'm on the line. I'm happy to help answer any questions. I think Rich did a good job in summarizing the call.
Okay, thanks. We can hear you well. Rich, the question is, why doesn't aging and degradation include steam generator issues, being that they are the second most problematic area after fuels?
Well, I think we have to. We have a limited budget. We have to pick the areas that we want to focus on, and I think the feeling is aging of steam generators is being addressed in the industry. You know, oftentimes through replacement. I understand that, but there's a lot of you know, industry involvement in the steam generators. So it's a good area, but it's not one that we chose for this year.
You mentioned lithium-6 for chemistry control. Are there any specific projects that you have in mind or are aware of?
We have some ongoing work with EPRI related to recycling of, it's actually lithium-7 that's used in plants for chemistry control. So most of the lithium-7 that's used in the plants is essentially thrown away at the end of the cycle, and then they have to add more lithium-7. All the lithium-7 enriched lithium that's enriched in lithium-7 is produced currently in Russia and China. So there's some concern about limited supply of lithium-7. So if we could recycle the material that's in the plants, and actually the boron that's added to the plants captures a neutron and decays lithium-7. So actually lithium-7 is produced in plants while they operate, but again, it's all thrown away as part of their waste stream currently. So we're working on a recycling of lithium-7 project. There's also some work related to technologies that might be used to enrich lithium-7. Lithium-7 would be needed for advanced reactors, particularly the molten salt reactor would need a lot of lithium-7. So there's technologies related to enrichment of lithium-7, and we're also looking at with EPRI at the possibility of switching the chemistry currently used in pressurized water plants, pressurized water reactors to potassium-based chemistry. So it would, by getting off of lithium, would solve some of the supply issues. But certainly changing chemistry in a plant is a big deal because it could affect the material degradation of plants if you change chemistry. So there is work going on related to potential chemistry-related degradation of materials that could occur if there's a switch. Actually, the feeling is that potassium might be better than lithium for chemistry control, but it's yet to be seen yet. There are some plants, particularly in Russia, that already use potassium chemistry. Let me see, I'm not sure I answered the question. I talked a lot about it, but did I answer what was the original question?
It was about lithium-6 and chemistry control.
Yeah, well, it's lithium-7.
Yeah.
But
Could you return to slide number 5?
is this slide 5? Which one's slide 5?
That's a good question.
That's slide 5 now.
Oh, yep,
Okay.
that's slide 5.
Are neural network methods for analyzing heterogeneous data streams of interest?
I think so, but I'll let Bruce maybe say something.
I think neural network approaches would be applicable, but it would be up to the proposer to advocate for how that's relevant and how that's applicable to the particular call. Again, you know, neural networks, I think, would work well, particularly for certain types of data. But again, you know, the particular proposal would have to establish how the neural networks were going to be used with what types of data, how that was valid and appropriate for the types of data, and what benefits, say, saw from that particular type of approach.
Are there any large heterogeneous data sets available within DOE, and will they be provided for research to perform fusion and advanced big data analytics?
I'll let Bruce talk to that.
You know, I'm not aware of any large data sets of heterogeneous data like what we're sort of envisioning here for improving or optimizing plant operational efficiency. And even if they were available in DOE, if they were from DOE, it wouldn't necessarily be applicable to the problem that at hand that we were proposing to target through this funded research. However, you know, the question raises an interesting point, which is, in order to do this research, in order to really demonstrate the research, might there need to be some sort of cooperative agreement developed with an operating nuclear utility to gain access to this type of data? So that is something that, you know, the proposal should identify, and if that's necessary, then on behalf of the proposal, if something was selected, we would attempt to try to reach out to a utility and establish some sort of an agreement like we have with other funded R&D activities ongoing currently, even with funded NEUP projects.
What sorts of specific insights are sought by analyzing heterogeneous data streams?
Well, I think that's up to the proposer. I mean, obviously, efficiency, economic and efficiency improvements are the focus, and so how the data could be used to, you know, provide those economic and efficiency improvements is up to the proposers. So, I don't know, Bruce, do you want to add anything to that?
Sure. I think that nuclear power plants have been advertising very openly the fact that they're under extreme cost pressure, both internally from, you know, rising costs and, you know, reducing revenues. And so when you look at that, a lot of it is, you know, internal factors. The fact that, you know, they're very labor intensive. So the question is, how can we use data from operational data to look at how to optimize work processes? How can we use data from operational work processes to improve safety? And so, you know, I would leave it up to the proposers to maybe, you know, contact an owner-operator, partner with them, look at available data in the literature from operating events and other sources to gain some insights as they develop their proposals. And also review some of our published research, because there is a lot of published research about some of the challenges that existing nuclear power plants face. So I think that'd be a good starting point.
Are there any preferred sensors for to develop the heterogeneous data stream?
I don't think this is the focus of this call is not really on the sensors. You know, they certainly could propose what data they would want to collect, and if a sensor was needed for that data, you know, I guess that would be a factor. But the focus is not on the sensors that would actually collect the data, but on what you would do with the data.
EPRI has a database, a performance demonstration for data analysis from the utilities. Is there the ability to get access to this database and use it for this scope and for RC5, excuse me?
Well, that would have to be probably worked with EPRI. Bruce, do you know can you add anything to that?
You know, through the Light Water Reactor Sustainability Program, we have a memorandum of understanding for research with EPRI, but you know, you've mentioned, the question has mentioned a very specific project and a specific data source. We don't currently have an agreement for using that particular data source, and so that's something that we would have to ask EPRI about. But I believe that the proposer could also contact EPRI about that as well too, and find out if they would be interested in supporting, you know, their proposed research through an application or use of the EPRI database.
Right, and the proposer could team with EPRI as part of their proposal, certainly.
Yeah, certainly.
Okay, those are all the questions we have for now in RC5. We will move on to the RC6 presentation. Please do know that you can continue to submit questions. We will have Bruce and Rich here for the next 45 minutes or so. So if you do have more RC5 questions, please feel free to submit them.
All right, well, moving on to the next call, RC6. This involves our risk-informed safety margin characterization area. And our research on risk-informed safety margin characterization supports a methodology for better understanding plant safety margins. A better understanding of how plant safety margins are changing, for example, with plant changes such as power uprates or with aging effects, would be helpful for decisions on plant investments. The methodology uses deterministic simulation of the plant with probabilities used for various scenario events in a Monte Carlo style analysis. This results in a distribution of outcomes. A set of tools are being developed that we hope will make this methodology practical for use by industry. Specific to long-term operation, we are looking at aging cycles such as irradiation, thermal stresses, and fatigue to better understand how they influence plant safety margin. So a little background in the RC6 area. One area of research is looking at potential risk and economic improvements that might be achieved at existing plants through the implementation of accident-tolerant plant designs, specifically focused on improvements in plant coping times. Seeking to leverage the RISMAC methodology and tools combined with the 10 CFR 5069 regulatory process to provide flexibility to reduce costs and improve plant operations and safety margins. 10 CFR 5069 has two parts. The first part is the use of risk analyses, including robust internal events and internal flooding risk models to categorize components. And the second part is to collaborate with engineering to determine the relaxed requirements associated with these recategorized components. This is termed risk-informed engineering programs. Potential enhancements may include advanced fuels, improved core structures, incorporation of flex equipment, or taking account of the use of flex equipment, use of passive cooling systems, either new or modified to existing equipment, and improved procedures and instrumentation. The research would evaluate plant scenarios using the RISMAC simulation tools to determine potential applicability of the different coping times using risk-informed approaches. This analysis will focus on determination of a response surface of coping times versus potential economic savings, with the goal to leverage the RISMAC methods and tools with the 10 CFR 5069 process to provide flexibility to reduce costs and improve plant operations and safety margins. The research will use the infrastructure that's been developed within the LWRS program. I think the infrastructure references to reports on that infrastructure is provided in the call. This area is looking at a broad set of potential changes or operational changes, either operational or changes, physical changes to the plant, but it's focused on the methodology to evaluate these changes and their impacts on economics, the cost of implementing these changes, and the safety at the plant. So that's it. Any questions? I think Diego Mandelli is on the line if he has anything either to add or if he can help me answer questions if they come up.
Diego, it seems that you are self-muted, so if you could go onto the GoToWebinar application and unmute your mic, then I believe we can hear you.
Can you guys hear me?
Yes, we can hear you.
Oh, okay. Okay, thank you very much.
So Diego, would you like to add anything before we start answering questions?
Not really. You covered this material pretty well.
Well, Relap 7 remains under development. Can proposals use more ready tools like Trace?
Yes, that would be acceptable.
Could you go back to slide 6?
That's in the RC5 area.
And there's another RC5 question, so I will, while we're waiting for any other questions, we'll open Bruce's mic back up. Is there any way to use IoT to collect data and use them for big data analytics?
So this is Bruce. Yeah, the Internet of Things. Internet of Things is sort of a broad categorization of communication protocols that are available from different devices to communicate wirelessly or using other communication protocols to transmit data. So IoT may be available. It depends upon the particular device, the particular components, but I would say, for plant components that are part of the plant instrumentation and control systems today, no. Well, not unless the sensor is added after the fact, and it wouldn't be for any control purposes. So it's just, IoT is possible for certain types of things, but it just depends on, what you're thinking about using it for. I know that's not a very clear answer, but it's, you're talking about a very general communications protocol and collection of communication protocols.
Moving back to questions on RC6, what flex equipment is expected to be available and how soon after an event?
Well, the flex equipment's, it's already in place at the plants and at the regional centers. I know there's a timeline for the flex equipment. I think the on-site flex equipment, they take credit for it, or they say it would be available within 24 hours, and I think the regional equipment would be available within 72 hours. I think that's the general outline for the plan that the industry has. But I think, if the flex equipment on site could be deployed sooner, maybe and you could demonstrate that that was the capability of the plant, then maybe you could take credit for that. So that the idea is if you have the equipment, you know, and maybe you could change the operational boundaries for that equipment. You know, you could take credit for that equipment. Right now, there's no credit in terms of the traditional safety analysis of the plant taken for the flex equipment currently. So I think that's part of the analysis would be looking at that. I'll call it flexibility of using the flex equipment and being able to take credit for it.
So Rich, we also have Ronaldo on the line to answer any questions. So
Oh, okay, good.
let me get his mic unmuted, and then we will. Ronaldo, are you there?
Hello. Yes, I'm here. Hello, everybody.
Yep.
Rich, how's it going?
All right.
I want to emphasize one point about the RC6. It's important to look at excellent tolerances in terms of system level. There is already a substantial program in the excellent tolerance fuel DOE program, and we are looking for more excellent tolerance features as a systems as opposed to just fuels analysis. So this is a topic that's that we're very interested in.
Yeah, so just to repeat what Ronaldo said, you know, this topic or this call is looking at the a systems analysis of the whole plant and how the whole plant would react to potential changes, which could include accident tolerant fuel, changes to the flex systems, other systems changes in the plant. So it's really looking at the performance, how the whole plant performs.
Correct. We looked at fuels as one system component in conjunction with everything else.
How broad is RC6 intended in regards to advanced features? Focus on ATF, core structure, and flex only, or something more?
I think we'd be open to any potential changes at the plant, but we are looking at existing plants, and we're looking at, you know, there's a lot of resistance naturally to making significant changes at existing plants due to the high cost. So, you know, if you're talking about, you know, ripping out the entire reactor pressure vessel and putting in a whole completely different core into an existing plant, I'd say that's probably not going to be realistic. You know, installing large, you know, systems in the plant that would take a major backfit are probably going to be, you know, not realistic. But if you install, you know, a single pump or a small system that could be done at a reasonable cost, you know, that could be done as part of other changes to the plant, you know, potentially. And so again, we also mentioned, you know, changes in operational use of some of the existing equipment, like the RIXI pumps or the aux feed water pumps, in different modes than they're currently used in order, again, to stretch out the coping time. So it's a combination of all these things and the potential for all these things that would make the most economic case for a plant. So part of the analysis has to include the economics. So there has to be essentially a business case. Why would it make sense to make these changes? How much would they cost? How would the plant perform better economically in the future that would make it more economic for these plants to operate in the long term? So the focus really is on the economics, I would say, the long-term economic viability of these plants. And so the changes would have to feed into that long-term economic viability by improving the situation.
Are any experiments associated with design enhancements such as ATF or improved operational control interesting?
We would not expect any type of experiments, if that's what they're asking, actual performance experiments related to these changes. So we're looking at the analysis methodologies, not actually testing the performance of the potential changes.
For RC6, it seems to be in conflict with RC7. Could you comment on the programmatic reasons for having the two areas?
Well, RC6, and we haven't talked about RC7 yet, but RC6 is focused on a systems analysis for the whole plant, looking at the economics of the changes. RC7 is focused on what changes could be done using existing systems to lengthen the coping time. So it's very specific to that scenario.
Is use of wireless devices allowed in nuclear power plants in the United States?
Yes.
This is a question for RC5. It sounds like RC5 is more focused on dealing with the large-scale nuclear data available within DOE. Is that a correct assumption?
No, it's focused on what data would be available at an operating nuclear power plant. So, DOE doesn't own any, not any large-scale commercial nuclear power plants. We have research reactors, but that's the type of data that would be interested in, not DOE data.
Moving back to RC6, are system analyses that look at the effect of river, ocean, and lake temperature rise on existing power operations interesting?
I suppose it could be included, potential changes in a plant's environment as part of an overall systems look. But again, the focus isn't on addressing, changes in flooding or seismic scenarios that could occur. It's focused on improving the economic performance of the plant.
Okay, Rich, those are all the questions that we have currently for RC6. Move on to the RC7 presentation and hold all questions till the end of that presentation.
All right, so this relates to our reactor safety technologies pathway. This pathway provides scientific and technical insights, data and analysis, and methods that can support industry efforts to enhance nuclear safety in a beyond design basis event scenarios. These activities evolved from a coordinated global effort to assist in the analysis of the Fukushima accident progression and response. And it has focused now in the following three areas. One is the Fukushima forensics and examination. So that's an ongoing area looking at, as they take the plant apart, what insights can be learned related to, and knowledge related to the accident progression from those examinations. Second area is severe accident analysis, and that's looking at supporting potential changes to how plants can best manage events in the severe accident space, including potential changes to severe accident management guidelines. And finally, we're looking at accident tolerant components. This mostly involves passive cooling technologies, looking at, in particular, at the existing reactor core isolation cooling pumps at the boiling water reactors, the ox-speed water pumps at the pressurized water reactors. These are Terry turbine pumps, and they were used at one of the units at Fukushima for 3 days, keeping the plant cool. So they're not really designed originally for this purpose, but they could be used if they were changed in their operational parameters. That at least they have the potential that they could provide cooling for a long period of time. So those are the three areas. Some background related to the call. We're looking for innovative concepts for increasing the ability of existing plants to passively respond to beyond design basis events. Within our program, we've been looking at two approaches to achieve this objective. One is the accident tolerant fuels program, or what industry likes to refer to as the advanced technology fuel, using the same acronym. But coupling this technology with extended emergency core cooling equipment. I mentioned the RIXI pumps and the ox-feed water pumps. Using these both in combination to delay or prevent core damage, essentially providing longer coping times. There are other methods. Another novel way that's been looked at is using existing structures and equipment within the containment to augment the long-term cooling, or providing an enhanced heat sink. And one example for that is flooding the drywall head in boiling water reactors in the Mark 1 and 2 containments. By providing the cooling water on the outside of the containment head, it would provide a path for heat to be dissipated from the core. So the RC7 proposal is looking for innovative methods for increasing the passive safety response for existing plants. We're seeking proposals that would explore these innovative methods for passive safety at existing plants. So the focus would be on the definition and analytical demonstration of these novel methods for increasing containment heat sink. So I think this would include, some potential testing of these methodologies, or validation of any models used for these methodologies, and evaluations of advanced technology fuel coupled with extended performance of emergency core cooling equipment, and use of the system level codes to demonstrate the effects of these two concepts on preventing or delaying core damage. The goal is to achieve a 72-hour coping period for an existing plant using existing equipment. And I think Mitch Farmer should be on the line if he wants to add anything to the description.
Mitch, we have unmuted you. Can you hear us?
Yeah, can you hear me?
Yes.
Okay, yeah, I'm here. I think Rich did a fine job explaining it, so I think we're both open to questions.
Okay, the first question is, many passive concepts have been designed for Gen 3 plus light water reactors. Are the passive concepts proposed within this work scope required to be totally new, or can we examine existing passive designs for the current fleet of commercial reactors?
Well, the focus is on existing plants. So if there was a Gen 3 plus, technology that it was developed, and it could be applied to an existing plant, then I think that would be definitely applicable. And so I think an AP1000 where they use cooling water outside the containment vessel during the early stages of an accident provide passive cooling, that's similar to flooding the dry well or the head of a BWR reactor. It provides a path for the heat to be rejected to the environment. So those are certainly applicable. Mitch, do you have anything to add to that?
Well, that pretty much covers it. I mean, as you said, we're looking at existing plants and ways that you can use things like natural convection, given the structures that exist in the plant without the less change to the plant to better to be able to get to that stage. That's what we're looking for. And then stitching this all together with ATF and other research areas that we're pursuing, which is increasing the operational envelope of RIXI and ox-feed water pump operation, how these can be stitched together from an engineering viewpoint. This is focused on engineering as opposed to the risk analysis that is in the RC6 pathway. So.
Do you prefer to cover both ATF-based approaches and other novel approaches, or to focus on novel approaches that are outside of ATF?
Well, there's a whole program related to accident-tolerant fuel, so the focus isn't on, developing novel accident-tolerant fuels as part of this call, but you can include an accident-tolerant fuel design as a proposed one element of a proposed, set of changes that you would make at a plant that could achieve the long-term coping time. So I wouldn't focus on the technology of accident-tolerant fuels, but you could pick one as a proposed methodology and also propose the characteristics of that fuel that you would expect to achieve and how that would fit into your analysis.
The RC7 work scope specifies using existing equipment. However, some modifications would need to be made in order to improve system response. What is the extent of acceptable modifications of new equipment additions that may be acceptable in this work scope? An example here is given, for example, a new type of injector.
Well, I wouldn't rule out anything in particular, but certainly we're focused on using existing equipment because that's much cheaper and easier to use. If we're talking about modifying the operational envelope of the existing equipment or how it's used, like the Rixey pump has lockouts and safety features that would have to be disabled for it to operate in a passive mode. Those are certainly all well within the scope. If it was a relatively minor backfit, that might be included, but if you're talking about major changes to the plant, I think it's realism in terms of its likelihood of being implemented start to drop.
Should economical safety solutions be a key element of this proposal?
I think so. I'm not sure exactly what that's referring to, but yes, I would say. Mitch, do you have any further thoughts?
Well, I would just say that is economics is clearly a key element of it, and that is tightly coupled to the extent of any modifications you would need to make to the plant. So the less changes you would have to make, it's more easy for industry to adopt it and use it, and the economics increases. So I think that's an important part of it. Like Rich said, if you're talking about any major modifications that affect safety systems, those are very costly. So the idea is to put on thinking caps and propose things that would be able to be integrated into the plant structures the way they are now and increase passive heat rejection, and then also incorporate some of the aspects that, ATF may be important, but if you can get there without it, that's even better. So the ultimate goal is to try to get to 72 hours with the core intact and without venting. And whatever you can do to get that, the prospects of the proposal increase. So